All right, on to the next one. Let's get started on creating our PM right here. We talked about this whole mess of a diagram here, but what we're going to build now is we're going to write the code for this presenter model. Now, this presenter model, we're going to take our entity changes. So the presenter model is going to be connected to a specific entity. It's going to register or subscribe to that entity, and then it's going to convert entity position, X, Y, the start and the end, PE and PS, or whatever those things were called, convert those into vector 3 for position and a vector 3 for orientation, or for rotation, an Euler vector, and also a length. And then we should be able to take those and create a view out of that. So let's get started. All right, so we come back over here. Let's put me over here. Let's get into our interface PMs folder. What we're going to do is we're going to start out by, whoops, it's the wrong one. Start out by writing this thing. We're going to call it tape measure PM. And we're going to go ahead and create a test for that called tape measure pm.test.ts. All right, and let's get these guys where I want them. We're going to close the others, and here's our test. Close the others. All right, so here's our actual test we got going on, or our class. Let's go ahead and build this out. So I'm going to go ahead and define the view model itself. So we're going to export an interface called tape measure VM, and let's see, we know it's got a position, PSITION, which is a vector 3. Oh, we don't want that from Babylon, we want our vector 3, so that's going to be let's do this. We can't import Babylon vectors because that would point to a framework, which is not great. So we use our own. We have our entity vector 3, so we'll use that for our position. We also need a rotation. ROTATI. And that's going to be a vector 3 as well. And then finally we have a length, which is a number. All right, great. So that is the view model we're going to send to the view. And we're going to now we just need to calculate these things. So let's go ahead and make our class. Since this is a subscription thing, we do have some persistent states in here. We're going to create a class. So we're going to export class called, oh, I spelled tape measure PM. Let's fix this while we're at it. Tape measure. And what do we need? Well, we're probably going to need our tape measure. I'm going to make this private though. And that is a tape measure entity, perfect. And we're going to need to keep track of our view. So we're going to call this private update view. And that's going to take the VM and it's a void function. So this is what we'll be handed this view to, and this is what we call when things have changed and we need to update. So let's go ahead and build our constructor. We've got our tape measure, which is a tape measure, and we have our update view callback. Update view, which is going to be this VM tape measure VM to a void, and we just store those. This dot tape measure going to be tape measure, and this dot update view is going to be update view. All right. Oh, why do we have an ID in there? Yeah, that should work. Little colon, semicolon at the end there. Okay, that's enough to get us going. Let's get our tests pointed at the right thing. And let's build over here. We're going to switch to our test function. So our just test, we're going to do a function called make test rig, and we're going to do this thing. Let's see, we know we need tape measures, so we're going to constant measure is going to equal go ahead and make it make tape tape measure, given an ID of tape 1, and we'll just attach it to stake 1. Doesn't really matter what we say here. So we do that, and then we're going to do this. Let's see. So that's our. We're going to do an. Oh, we need our update function. Update view. It's going to equal adjust. We're just going to use a just function for that, and we're going to return these two. Oh wait, we need our controller or our PM. So constant PM equals new tape measure PM, and we're going to pass in our tape measure and our update view. There we go, and then we'll return all these things as an object so we can grab them as we need them. Tape measure, update view, and PM. Okay, there's our test rig. Let's move on to our first test. I don't want to do that. Test. First test is let's ensure that the view is initialized. So we want our view to be called when we create this thing. And we just want to make sure it's called. We're not really going to check anything. We're just going to make sure it's initialized. So what we're going to say here is constant view update view and equals test. No, make test rig, and we just expect our update view to be called. All right. We should probably make sure. Let's see. Let's go ahead and put in some positions for our tape measure. So our tape measure, let's just pick some nice positions that we can work with. So let me flip over to our diagram we've been working on here. Get my Wacom tablet back out. So for testing, what do we want? Let's we're just going to put, let's see, let's call this 0, 0. So this will be our origin. Let's start our tape at 1, 1. So this is going to be 1, 1. And this is going to be PS. And then let's end our tape at something, how can we do this so the math isn't too hard? We don't need to make the math hard. Let's just keep it right along the Z. So we're going to end it here at 1, 2, 4, 5, 6, 7. So this is going to be PE is going to be, let's see, it's going to be 7. No, it's going to be 8. We're coming off of here. So 1, 4, 5, 6, 7. It's going to be 8 here and 1 in the Y. So we know now for our VM. So when we go from Unity, when we go from our 2D plane to Unity, we, essentially the way it works is X goes to X, Y is equal to 0, and X goes to X, Z goes to, no, dang it. Let's erase this stuff. X goes to X from our 2D, Y goes to Z, and Y is equal to 0. All right. And then also we know that theta is, if we did, well, see, we don't have a theta in here now. We'll work on that. So we'll start here. So we should expect, let's see, we're gonna set it up so in Babylon, the PS, so the position will be this spot. The rotation will be around this spot, and the length will be this way. So we expect P position to equal, let's see, it's going to be 1, 0, 1. We expect the rotation to be 0, 0, 0 because we don't have any rotation. So it's 0, 0, 0. And we expect the length to equal 7 because we're going from 8 minus 1. So this is what we expect to come out. So with that in mind, let's flip back over to code. All right, so we're going to expect that to be called. Let's go ahead and take our update. We're going to get our constant. VM is going to be update view mock.calls 0. It's the first parameter. This is going to be as a, I'm going to cast this as a tape measure VM. Okay. Up here we need to set our tape measure. Tape measure set. What do we call it? Start point. Start point is going to be equal make vector 2, and we said that was going to be 1 1. And tape measure endpoint is going to be make vector 2, and that's going to be 8, 1. All right. So now we got this, and now we can do our expect. We can check our other variables too. Expect vm.length. That's going to be the one to equal 7. We're going to expect vm.position. We have this way that I can cast this into an array. Makes it easier to test the jest stuff. And we said that was going to be 1, 0, 1. And we then expect the rotation to be to equal 0, 0, 0. It's aligned. Yeah, we don't want any rotation. Okay, so as expected, we're failing because, well, we haven't written any code. So let's go and do this. So we're going to make a little function over here called do update view, and this is going to be responsible. I'm going to actually make this an arrow function since we're going to be dealing with this parameter here. This will be responsible for kicking off. So we're going to initialize here by doing this dot do update view. So that'll kick it off. First thing we need to do is calculate our home positions. That's the start position of this guy. So we're going to say constant position is going to is going to equal make vector 3, and it's going to be VM. Oh, we need to be past our VM. No. Wait. No, we don't. We make the VM. We're not past the VM. So position is going to be equal to this. Oh, we're going to do a make vector 3, and it's going to be our tape measure dot start point dot x, a 0, and then this dot tape measure dot start point dot y. Okay. We won't worry about calculating the rotation yet. We'll get that. We'll handle that when we write a test. So we're just going to do a constant rotation is going to be equal to make vector 3, and we're just going to start this out as 0, 0, 0. And you know what? I'm going to go ahead and, just to make these guys more convenient, I'm going to cast these guys, get these guys out here. So this dot, we're going to call this start. Is going to be this dot tape measure dot start point, and we're going to have a constant dot end. It's going to be this dot tape measure dot end point. All right, and then we can quickly get, let's go ahead and use these guys in here. Here, start dot y and start dot x. Rotation is fine, and constant length, it's going to be start. How do we want to do that? Do I have a way to do that? We're going to have a delta. Constant delta is going to equal, let's see, we want to do the, we're going to do the end, subtract the start. All right, so that's our line. And so delta dot magnitude is going to be the length. And then now we can form this up into a VM. I'm going to go ahead and cast this into a tape measure view model, and that's going to equal position, rotation, and length. And then we shouldn't have this in here. Then we do this dot update view VM. Boom. There we go. Let's see if that passes. I would expect it to pass at this point. Cool. All right, next thing. we want to make sure that our VM updates whenever our tape measure updates. So we're going to do this. The view updates when the entity changes. So what we're going to do is, we already know we get initialization, so let's go ahead and do this update view dot clear. That'll clear out that initialization call. We need to grab our tape measures. Now what we should do is let's just move. So let's go back to our picture here. What we're going to do is let's just move this. Let's move this back to, we're going to change the end to be like something like 5, 1. All right, and so that'll drop our length down to, our length is the only thing that should change, and our length should go to 5 minus 1 should be go to 4. So let's do that. So we're going to come over here and we're going to say, okay, tape measure set. We're going to say the end point is going to be equal to make vector 2. And what do we say? 5, 1. Now we're going to expect our thing to be called. We're going to expect our position to be the same, but we're going to expect our length to go down to, expect our length to go down to 5. 4 is what we're saying. Update views when the, I'm going to say end point changes. Okay. Okay. Let's see what we got. It's not going to do anything because we haven't subscribed. So now let's go ahead and add our subscription. This dot tape measures dot add observer, and we're going to say this dot do update view. All right, so that should work. Since we subscribed, let's also take care of unsubscribing or disposing, because this view could get deleted, and we want to make sure we release that subscription. So we're going to do test PM can be unsubscribed. Okay, and so we're going to do this exact same kind of stuff as this, except we're going to grab a PM here. Actually, we're going to grab this tape measure too. And this is actually the kind of logic we want to follow. So we're going to do this, and we're going to do a mock clear, and then we're going to do this. We need a PM on this one. Bring our PM. Let's do a PM dot dispose. Now we're going to do our move our tape measure, and then we're going to expect our observer not to be called because we unsubscribed, or we disposed of our PM. And so even though our entity is changing, we shouldn't be updating our view anymore. So we're going to add a little function over here called dispose and make that an arrow function. Oops. And we're going to do a this dot tape measure dot remove observer this dot do update view. That's how we dispose. We unsubscribe, everything should be cleared up. Perfect, looking good. All right, let's check this one. The view updates when the start point changes. Really don't need to do too much when the start point changes. So now we want to, let's see, we have start point at 1, 1. Let's just bump our start point a little bit to the left. So we're going to say start point is going to go to, let's keep it up in the y. That way we're still on a straight line. We'll do the angles in a minute. The reason why I don't want to do angles now is because we're checking I can check the length this way pretty easily. So let's go -1. So that's going to go from now -1 in the x all the way over to 8 in the x. So that's going to give us a length of 8, 9. And it's going to move our position to this point. So this should become -1. Still up in the z. Yeah, z is the y how it's mapped. All right, let's see if that worked. Cool, that worked. All right, finally, let's check rotation. Okay, so our starting point changes or ending point changes. And let's just check our test the rotation vector. Okay, so let's come down here. All we're going to worry about is rotation. We're going to start it out at 0, 0. We've already done that test, so we don't really need to do that again. Let's try a 90. So if we come back over to here, what we're going to do is, let me try to sketch way over here with my Wacom. So we're going to keep, so this is still 0 origin here. So this will be the start. PS is still 1, 1. We were way over here, but let's rotate this up to say here. So this will be PE, and it's going to be, let's see, 1, 2, 3, 4, 5 in the Y. So it's going to be 1 and 5. But we know that our theta, so our theta is this way, and it's from this point to this point, so it's 90 degrees. But also we're going to Babylon, so we know that we need it to be in radians. So it's going to be 90 degrees in radians, which is what, half pi, half of a pi. Yeah, it's half pi. So and it should be. Actually, another tricky thing is this should be negative. I think in Unity for some reason I think it's a right hand left hand rule. I don't know. It should be. We expect it to be a negative. So the Euler vector should be 0, negative pi over 2, and 0 is what we expect it to be. So try that out. So let's get over here to this test again. Now expect our, okay, we're going to do this, but this time what are we going to put our stuff to? We're going to put it to 1, 5. So we're going to put the in position. Oh, let's grab the end position from up here. Here we go. End point. We're going to rotate it up to 1, 5. We can go ahead and check our dimension, our length too. Make sure that's getting calculated right. So we're going from 1 to 5. So it should be a length of 4. So back over to here, we should expect. Well, let's just do all these guys again. Might as well. Be thorough. So we're going to expect the length to be 4. We're going to expect the start position to still be 1, 1. But this time we expect this to be negative math.pi, not pow, pi divided by 2. Let me think through that, make sure that's right. I think it is. Okay, now we come over here. We have to calculate our rotation vector. So we already have our delta. Now, our delta, because it's a vector I made, we can get our theta. Which is going to be delta dot angle theta. There we go. So this is our theta, but since I wrote this vector, I know it is it's going to tell us the rotation in degrees of this. Essentially, this is the vector that's pointing from start to finish, and theta is the angle of that vector as it rotates around the 4 quadrants in degrees. So we need to do constant theta in radians is going to be theta, what is it? Theta in degrees Gosh, I haven't looked that up for it. Actually, I have a thing for this. Convert. Let's see. Do we have radians? 2 degrees. There we go. Got that. Now this should be negative radians 2 degrees. Let's see. So slow. My goodness. 12 seconds to do that. 4 failed. Oh, I did radians 2 degrees to whoops. Degrees to radians. Let's do that one. Let's see how that works. Okay. Here's a weird little thing. We can get a -0. So I'm taking this theta. Most of the other tests, this theta is a 0. Theta 0 can be negative. It's annoying. Okay, here's what we're going to do. We're going to do a -1 times that right there, and we're going to take it out of here. I'm going to call this. And we're going to change this to, no, we'll call it that. Still getting a -1. Okay, dealt with the monkey business. I just did a inline check to see if our theta is 0. If so, we just leave it alone. Otherwise, we negate it. Silly how a -0 is not equal to a 0. But that's how it is. So, anyways, we got our test pass in there. I think we might be good to go. Let me think through this for a second. So, we've got our update view. We've checked our angles. We've checked our length multiple times. We've checked our positions. So, great. So now you can kind of see, like, we have taken that entity, we have converted it to a bunch of stuff using some math here, some logic that we can test and make sure it's robust and doing what we want. And we're converting it to a vector 3 for a position, a rotation, and a length. And now that we have that done, we can move over to our view and get a view component hooked up to this guy. We're going to go ahead and stop this video. Next, we'll write a view.